Says here that we had someone waiting for the live stream. So
Wow.
yeah, well,
We're going to have to start tracking numbers on these.
yeah,
Make it be a KPI.
that's not good. Let me turn notifications off. All right. Okay. And we are live.
All right.
Can you see, you can't see the screen right now, right? Because you only have one screen on that setup.
Yeah. Yeah.
All right. Greensdale is asking on Instagram what we're doing. We're doing a live stream. We were just getting ready. We were setting things up here on YouTube. So if you want to join the live stream, follow the link in my bio.
And in a minute, we're going to be doing a demo for our little program our product called the Robby framework.
I don't see anyone yet, but I guess we can continually we can start, and the video will be there so for people to watch it later. So if you wanna start, telling us what the demo is going to be about.
Yeah. Yeah. I can do that. So what we're going to do, uh, first, I want to talk a little bit, I guess, about kind of how the framework works and what the pieces of it are that you work with. So the Robby framework is for building robotic control programs. And the way it works is you build networks using the UI that's included with the framework. And networks consist of three main pieces. They're message schemas, which control the shape and content of JSON messages that pass through the network. Connectors, which connect the network to individual devices or protocols or services. Tonight, we're going to play with the serial connector that hooks up using serial protocol and can be used to talk to Arduino cards or Raspberry Pis or anything that talks serial communication kind of generically. Excuse me. So let's talk about what we're going to actually be doing with the network tonight. We're going to be talking to this little Arduino Mega card here, and it's running a sketch. This sketch here, this is actually a sketch we use on our robot project called Antwerp. And this sketch is used for running a T800 power supply card, which can have 6 different power circuits on it and allows you to programmatically turn those circuits on and off. So these are the circuits that we play with here. And these are all circuits on our actual robot. It's not too noteworthy. It's just taking in serial communication that come in, and then it's providing a feedback message back. One thing I do want to look at real quickly here is these two header files, power control command message and power feedback message. These are header files that define little model classes that match message schemas for messages coming into the card and coming back from the card. So the power control command message is for messages coming down from what we call the master control program, which is the C# program you write to actually talk to the network we're going to build. And then the power feedback messages for messages, a response message that comes back from the Arduino card to the MCP. And just real quickly while we're in here, just to kind of show what we're doing, we're going to use the serial monitor in the Arduino IDE This is the power control command message. And you see it's got three properties: circuit, digital pin, on, off, and command message that we can send. Excuse me. So if I hit send on this, that sends into the Arduino card, and this is the feedback message that's going to come back from the card. So I just wanted to show that so later on you can kind of understand that that's what's going through the Arduino card. Okay, so I'm going to go ahead and run the Robby framework UI. And first we'll look at how the schemas are built. I'm not going to build them here because it's kind of tedious to watch, but you can see here what we're talking about. This is the power command control command message with the three properties here: on, off, circuit command, and circuit digital pin. Now, those header files that were in that sketch, those are created by pushing this button here, the C++ button on this dialog. When I push that, that actually creates those .h and .cpp files for those model classes that match the schema. One other thing we'll look at real quickly here is this JSON button. So as we're building up the network, what's really going on in the background, we're building JSON. And this JSON button allows us to see that JSON that we're building. You can also download it, and you can do whatever you want with this JSON, but you can't directly change it, or at least if you change it, it's not going to affect how the schema looks to the network. The JSON that's actually used by the network is encrypted so that you can't directly change it. You can only change it through the UI. So that's the power control command message. And then we'll just take a quick look here. This is the power feedback message, and you can see the properties here: pin, state, and circuit warning. So you can get a warning from the T800 shield if there's a problem, and that would show up here.
So Lee, I have a question. So are these messages that you pre-built?
Well, the schema is. The messages, the actual messages are going to be built in the MCP and passed, but they have to match the schema.
Okay, so how do you populate that drop down where you just were select message schema? Okay.
This is from building. These are all different message schemas here.
Okay.
So they all get built within this dialog.
Okay.
And I put in a property name and a property type, and then hit this plus, and it'll go on there. I don't want to change this one, but.
Okay. So this is something that the user has control over.
Yes, this is, you define the shape of messages that are going to pass through the network in advance here. And that's what this is doing. This controls any messages that come through. So every time a message comes in to a device or to the MCP, it's going to get checked against the schemas for the channel that you're talking to, and can only be passed through if it matches the schema for that channel.
Okay.
So let's take a quick look at building a channel here. We'll actually go ahead and build up this channel. Oh dear, I didn't get rid of it first, but let's get rid of it. Okay. So channels are made up of schemas like we just talked about. Each channel has two schemas. One is for messages coming from the MCP and out to devices, and we call that the from MCP message schema. And that's going to be this power command control command message. So we're going to send command messages out to the power card or the power shield. And then for device messages coming back from the Arduino card into the MCP, those are from device messages. And we're going to use the power feedback message for that. Now we're going to start dragging connectors onto the channel. So the first one here, this will be a serial connector that's going to connect this to the Arduino card. First thing we have to do is give it a name. So we're going to call this the demo power. Oh, I hate it. For some reason, I always capitalize my E's. Demo power device connector. And we're going to give it a baud rate of 115,200. And I know it's on COM port 6. And I'm going to check this box here, which says force wait for response. So one of the things we can do here, and we're going to do in this case, is make this communication synchronous. So when I send a message out to the card, further messages are blocked and queued until I get the response back from the card. And we'll demonstrate that here when we test the network in just a minute. So that's our device connector. Now I'm going to put a MCP connector out here. And this is called a string connector, and it's the simplest connector in there. And all it really does is passes string messages coming from the MCP on out to a device. So I'm going to call this the demo power MCP connector. And one other thing we have to do with these is to tell it which device connector we want it to send its messages to. So I could have multiple device connectors out here and multiple MCP connectors, and then I can control when I'm sending messages from the MCP on out to the channel, I can control which device connectors those messages are going to go to by setting this up here. In this case, we've only got the one connector, so I select that one, and that's all we're going to do. Now we've got one more thing to do with the channel here, which is I'm going to drag a couple of these gadget connectors onto it, which these are just little UI elements, which we're going to show in a minute here when we test the network. They get used in our testing console. So they configure here. They can connect, you connect them to one of the connectors on the channel and say which type of messages you want to display in it. So this one's going to connect to the MCP connector, and it's going to display MCP messages. And this one's going to connect to the device connector, and it's going to display the from device messages. And that is our channel. I have to give the channel a name here. So we're going to call this the demo power channel. And I'm going to save that off and close. Well, I'm going to save it, but before I close, just going to go take a quick look. This is the JSON we created in the background. So you can see those connectors. This is the configuration for those connectors for this channel. Okay. So then the last thing we need to do is go ahead and create a network, which I think I've already got the network out here, but oh no, I managed to. Okay, I deleted it when I deleted the channel. That's right. Okay, so networks are super simple to do. All I got to do is give it a name. So we're just going to call this the demo network. And all I'm going to do is take that channel that I created and drag it on there and then save it. And we'll take a fast look at the JSON here. So this is all the JSON for the network. If it had multiple channels, you'd see everything it took for each channel, including the schemas and all the connectors that are on that channel. And we're going to save that and close it. So we've got our network now. And now we're going to come out and test that network. And hopefully, if all's right with the world, it's going to work. So the first thing I do here, we're in what we call the main console, which is this main form of the UI. I'm going to select our demo network. And one thing to note here, we've got these little green icons. That it's green and not red tells us it's able to see that Arduino card out there, and it thinks at least that it's ready to talk to it. So
And
I'm going to open up.
So, like, how do you determine whether the device, the Arduino card, is available or not? Is it because you're looking at the port, the COM port?
Yes. So every time I load a network into the console, or load a network anywhere, anytime I instance a network, whether I do it in the console or in an MCP, each of the connectors has what it calls its start method on there, and it runs the start method, which it runs a little self-test routine that determines if it can make that connection right now or not. And if it can't, it'll still load the network. But in this case, that icon would be red to let us know, okay, yeah, I've loaded it, but it's not really connected to anything as near as I can tell. So you kind of get a
Okay.
warning.
Okay.
So I'm going to go ahead and open up the testing console. So these are those two gadget connectors. So from MCP to device messages and device to MCP messages. And here you can see the connectors they're going to talk to and the channel that they're going to talk to.
So these are mainly used to see the traffic that's happening, the
That's right.
communications going back and forth, right?
That's right, in real time. And this just gives you a way, before you write any code or do anything with an MCP, this is a way to find out if your network's actually going to work for you. So the first step here is to select the channel we want to talk to. We only got the one here. And I'm going to tell it I want to send messages into that MCP connector. And I push this button and it's going to allow me to actually build a message. So you can see here, this is building into that message schema, circuit digital pin, on, off, and circuit command. So I'm going to tell it I want to set pin 4 to on, and I'm just going to send the word test into it. That's not really going to do anything at this point. And we're going to save that off. So here you can see it's constructed the JSON that it's going to send. And I'm going to push this button here. And if all's right with the world, we're going to see that go to the card and come back. So here's the message going out to the card. You can see the power control command message schema here with the on, off, and circuit command. And here's the feedback message coming back showing that digital pin 4 was set to pin state of true, and there was no warning coming back from the power shield. So our network is up and running. And I said I'd demonstrate this synchronous communication here. So what I'm going to do, I'm going to hit this button real fast a bunch of times. And you can see that it's queuing those messages up and waiting for responses before it sends the next one, and it sends them one at a time. So that is the network, and that is the short little demo. So I'm figuring next time what I'm going to do is I'll take this same network and I'm going to build it into an MCP, and we'll build the MCP in Visual Studio and demonstrate actually using the network within an actual program. And that's that.
Okay, so now let's compare if you were to have done this without the framework, without the Robby framework, how long would it have taken you to do this simple test?
Well, so first off, you'd have to write all the code to do the serial communication with the Arduino. So when we came out here and did this little configuration here, well, that's really a fairly complex class that has to have its own worker thread, that's a listener thread that's listening to the Arduino, and all of that has to be set up. This is what connectors are all about. They're abstracting all the code it takes to talk to that thing. And it makes it so that you'll see when we do, actually I can bring up an MCP and just show, since we're kind of still at it here. This is an actual MCP program, or an MCP class that's derived from MCP control program, master control program base, which is a class that we bring in from this master control program lib that's exposed by the framework. Next week, I'll flesh this out and show it working, but just real briefly here, we receive messages like this by subscribing to this event that comes off of the MCP base class and then handling it with an event handler down here. So the messages come in, it's got the JSON packed into it for the model class. I deserialize the JSON into the actual model class, which is generated by the framework, the power control command message, or this is power feedback message in this case because it's the message coming back. And then when I want to send a message out, I use this send message to channel function that's part of the base class. And I pack it up into this MCP message event args class, which is just a standard event arguments class that tells it which channel I want to send to, which MCP connector on that channel I want to send to, and then sends it off to the channel. So pretty simple stuff. We've taken all that code that it would have taken to communicate, do the serial communication, and you don't have to do any of that. You just use this function here to send messages out and this little event handler to catch the messages coming back in. And this is the same regardless of what you're talking to, whether I'm sending messages out to Azure Custom Vision to do object recognition. It's really still just these same things. I have a model class that I send out using the send message to channel that would send it out to that service, and then I would get the response back as the same kind of event. It's all exactly the same always.
Okay. So we have a question. They're asking, or he's asking, did you use MCP 23017? Does that ring a bell? Or maybe this is
no,
or maybe it's a joke.
it might be.
That
is this what's that guy's name?
His name is Michael.
This is different.
No, it's the same one. Remember, I used to call him AED.
Yeah.
I didn't know his name. Yeah. So his name is Michael.
Okay. Yeah, no, this is MCP, like master control program that's just off of the base class.
He's saying that it's the Arduino MCP.
Arduino, I don't know. I didn't know there was an Arduino MCP. Wow. Okay. What is the Arduino MCP? Because the MCP in this case is the master control program that you write in C# that is used to talk to all devices, not just Arduinos. But that's interesting. There's something to do with the Arduino that's called an MCP. What does it stand for?
Yeah, that's interesting.
Yeah, I'm gonna Google that. Oh, I can't. Well, yeah, I can. I can just do this.
I can stop sharing your screen.
Oh, yeah, let's do that. We're done with this part anyway. Arduino MCP. MCP 2515. Oh, it's a CAN thing. Wow. For CAN bus. No, got nothing to do with that. With CAN buses or anything like that. That's interesting. They have an MCP, though. I don't know what the MCP stands for in their case. Presumably microcontroller or module or something. In our case, it means master control program. Here it's got something to do with their CAN bus module. Which CAN, I'm trying to remember, I've read about CAN and played with it a little bit. And it's a protocol for, I can't even remember now. But it's for one of these things. Oh, I'm not sharing my screen anymore.
Microcontroller process, he says.
Okay, microcontroller process. Okay. Yeah, no, it's not. Doesn't have anything to do with that actually. But it's interesting to know because it could cause confusion for people. I'll have to. For us, it's master control program and it's purely internal to the Robby framework. We getting any more questions out there?
No.
So is Michael our only guy this week?
Yeah, there. We had other people, but he's the one who stuck around. He's saying that the MCP, the Arduino MCP, is written in C.
Right. Yeah. Yeah. That makes sense. And ours is written in C sharp. Real dead simple C sharp. So I should have done the whole thing, I guess. It ended up being pretty short there.
Yeah, but it's okay. It gives us something to look forward to in the next episode.
Well, I didn't want to drag it on too long for people. These people's eyes start glazing over and they start clicking off, I figure.
Yeah.
But I'll try and
And
do something more interesting with it.
Michael, he gave me a link the other day. When was it? I think it was last week. He gave me a link for me to share with you. It was right after our last live stream, Lee.
Uh-huh.
He sent me a link, but the thing is that it's on my phone, and my phone is live streaming on Instagram right now.
Well, I guess you're going to have to wait till after we get done.
Yeah.
Well, what's the link do?
No, it was something related to the cloud editor,
Oh, the
or
Arduino IDE cloud version.
yeah, yeah.
Ah,
I think that's what it was.
I started to look at that and then got distracted. I've been working on the robot arm all week, which has been a real ordeal. It's been kind of interesting.
How's that going?
Well, I think I'm almost there. So I figured out what the original problem was. I told you that I'm using this old Trosson Robotics arm
Hmm.
that you relied on this Arbotics card that they created, actually, that Trosson Robotics created, and they created all the code behind it. And since this arm's like 3 years old, that all became obsolete. And I thought it died. I thought the card died, which was okay because you had to use an old version of the Arduino IDE to even upload to the card. It used 1.0.6. You had to use that to do anything with the card, so it was a real pain. So everything quit working, and I switched over to use this Dynamixel shield from Robotis. All the servos in the arm are Dynamixel servos, which are kind of special. Most servos just talk to a PWM pin on a controller card and use pulse wave modulation to change voltage, and that determines the position of a servo. But these Dynamixels, you can daisy chain them together and give them IDs so that they can hook with one TTL connector up for as many, I think, up to 200 different servos if you want.
Okay.
So in this case, there's 6 servos that run the arm, and each one has an ID, and they're all daisy chained together. So I got this Dynamixel shield that you put onto an Arduino Uno that allows you to do that, allows you to communicate with the Dynamixel servos.
Okay.
But boy, was that ever a chore to get going. And I'm still not quite all the way there. Part of it's because the servos are all 3 years old and largely obsolete, but they do still work. And they work with the shield, but you have to kind of jump through some hoops. And once I got it all going, I finally figured out the real problem all along was that one of the servos dropped its ID and was conflicting with another servo. I had 2 servo ones with an ID of 1.
Oh, okay.
That was causing, I think that was the fundamental problem all along, but I'm happy to get rid of the Arbotics card anyway, since they don't make them anymore. Anything goes wrong with it and you're on your own.
Okay.
But now I'm down to, I've got everything where it's talking to the servos, but I can't move the servos yet. And it's something to do with them being old and they had changed protocols at some point. So there's protocol 1 and protocol 2. And I haven't figured out how to move them using protocol 1 yet, but I'm sure I'll get there. I'm close now. After, boy, I did a lot a lot of thinking I wasn't going to get there, and it was really all broken, and nothing was ever going to work, and my $1,700 arm was going to be gone. But I think there's light at the end of the tunnel, and there will be an arm soon.
All right, that's pretty cool.
Yeah, it was quite a week.
Nice. And you didn't do any more work on the SLAM functionality you were working on?
Not yet. I've got to get back to it. I wanted to get the arm going because I want to start getting some videos of the arm actually posing. And
yeah, that would be pretty cool.
Yeah, and lifting things. I think it'll make interesting video stuff to get on the website.
Yeah, and then I still have to edit that footage that we got last weekend.
Yeah, yeah. And that's something, I can get into some of that if you want. I think I can loosen up some time.
Yeah,
I'm kind of in splitting that between doing these technical things and then also press release, trying to get the press release together and pitch decks and all the different stuff we're doing to try and actually start a company.
Yeah, there's a lot of work involved.
Yep.
I wish I had more time to help you, leads.
Someday we'll actually be able to hire you full time.
Yes.
I'm much cheaper.
All right, Lee. Well, I think I don't know if Michael left, but
yeah. Yeah, it looks like this was kind of a brief one this week.
Yeah. So then what I'll do, I'll plan the next one same time. I'm gonna say I scheduled this one for 5:20. So I'll do the same thing for the next one. Same day, so that way the audience starts getting used to that.
Yeah,
this time we're gonna
we need
show
to
up.
slowly build up an expectation here, especially after starting it and then stopping, and we're going to need to get a routine going and build an expectation that people can rely on and have it actually happen.
Yep.
Imagine that.
Yeah. So Michael said, "No, I didn't leave. I'm still here."
Well, good. We have, you're our best customer so far, Michael. You ought to build a robot, man, and we can help you build it with Robby.
Yeah.
I can
well,
show
all
you
right,
how to
everyone.
get all the stuff.
Yeah, Michael. Hopefully, we'll see you on the next live stream.
Same place, same time.
Yeah, I'm glad you were able to make it down. Oh no, he said that he was streaming from Mars. He didn't have to come all the way here. He's just watching.
Well, yeah, you got to send us some snapshots of Mars here at some point.
Yep. Maybe one of these days he'll join the live stream from Mars.
Yeah, that'd be cool. All right.
All right. Well, have a good evening, everybody, and thanks everybody for your time.
Yeah, thank you, everyone.
All right. Thanks, everyone.